Good morning to everyone. Today we'll discuss regarding types of ligands. Totally three types of ligands are present. So one is unidentate, the another name is monodentate ligand, the another one is bidentate ligand, the last one is polydentate ligand. Okay. So in the previous class we discussed regarding metal ion and also we discussed regarding ligand. Okay na? Suppose this is a central metal ion, this is a ligand. So always the ligand will donate the electron pair to the central metal ion. Okay. So next, this ligand also generally we can see three types. Maybe it may be either neutral or it may be either ionic. Ionic, either it may be containing negative charge, either it may be containing positive charge. Neutral, negative or positive charge. Okay now. So based on that, again generally based on the donating atom, the ligands are classified into three types. Okay, so first we'll go for uni or monodentate ligand. So it will donate only one electron pair to the coordinate with the central metal ion. So that's why we call as unidentate ligand. Okay, donating only one electron pair to the central metal ion. One electron pair to the central metal ion. That's why we called as uni or monodentate ligand. The best examples you can take here NH3. NH3 is nothing but what? Amine, donating one electron pair to the central metal atom. Okay, now that's why we called as it is unidentate ligand. So this amine is a neutral. So that's why we called as it is unidentate neutral ligand or monodentate neutral ligand. Suppose you take an example as Cl minus chlorido. It is also donating one electron pair to the central metal atom, but it bearing negative charge. That's why we call as unidentate or monodentate negative ligand. Okay. So next we'll go for bidentate ligand. So the name itself is donating two electron pairs. Donating two electron pairs it coordinate with the central metal ion. Okay, suppose I'm taking an example as C2O4 2 minus. So this is nothing but what? Oxalate ion. Oxalate ion, totally 2 carbons 4 oxygen, but charge is 2 minus. The charge is 2 minus. You can see the structure of this oxalate ion. Here you can see O minus, O minus. So totally two donor atoms to the central metal ion. So that's why it is called as bidentate ligand. Okay, but it is a negative charge. That's why it is called as a bidentate negative ligand. Okay, so next we'll go for another example, ethylene diamine. Total how many carbons are there? Two carbons. Ethylene diamine. That's why two amine groups. So that's why the name itself ethylene diamine. Each nitrogen will contain one lone pair of electron. So that's why the lone pair of electron, the another lone pair electron is donating to the central metal atom. So that's why it is a bidentate. Generally it's called as bidentate neutral ligand. Why? Because it containing only lone pair of electrons. So next we'll go for the polydentate ligand. The polydentate ligand is nothing but what? It donating more than two donor atoms. Instead of two, more than two donor atoms. So it can donate three donor atoms. That's why we call as tridentate. It can donate four. That's why we call as tetradentate. It can donate five. We call as pentadentate. Suppose it is donating six. We call as hexadentate ligand. Okay. Suppose we'll take an example as diene. Diene. So the name diethylene triamine. Diethylene triamine. Total how many ethylene groups are there? Two ethylene groups. How many amines are there? Three amines. Diethylene triamine. I will write the structure of that. Total diethylene. Two ethylene groups. So we can write like this: NH2, CH2, CH2. Next we can write as NH, CH2, CH2, NH2. So this is nothing but what? Diethylene triamine. Okay, so in this, how many electron donor atoms are there? Three. One, two, three. So that's why the name itself, it is tridentate. All three are amine groups. It is a neutral. That's why tridentate neutral. Generally we call as neutral tridentate neutral ligand. So this is one of the examples which is comes under tridentate ligand. So next we'll go for uh, another some more examples regarding polydentate ligand. Polydentate ligands, you can see here diene, triene. Okay na? So next you can see here ethylene, EDTA, 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 ethylene diamine tetraacetic acid. So in this example you can see how many donor atoms are present, totally 6. So that's why it comes under hexadentate ligand. It comes under hexadentate ligand. Hexadentate dentate ligand. It comes under hexadentate ligand. Okay, you can see this is a structure of ethylene diamine. So in this structure, two nitrogen groups and O minus, O minus, O minus, O minus. Totally how many are there? 6. So this 6 will donate to the central metal atom. So that's why we called as this is an example for hexadentate ligand. But the charge is -4, even though it donating 6 electron pair, but the charge is -4. Okay. So next we'll go for chelating ligands or chelates. So generally the bidentate or donate 2 electron pair, or uh, polydentate ligand, it donate more than 2 electron pairs. We donate the ligand will donate electrons pair to the central metal atom. So there is a formation of ring structure between the metal and ligand. So this is nothing but as chelate. Then the ligand is called as a chelating ligand. The ligand is called as a chelating ligand. Okay, we'll see example for the chelating ligand. Okay, you can see here. So is in this example ethylene diamine. Just now we explained ethylene diamine is an example of our bidentate ligand. So in this example, what will happen here? It donating to the metal, central metal atom. Okay, so there is a formation of ring structure between the metal and ligand. So there is a formation of 5-membered ring structure. Okay, a 5-membered ring structure. One, two, three, four, five. 5-membered ring structure between the metal and ligand. Okay, so that's why a ring structure between the metal and ligand. The ligand is chelating. That's why we call it as a chelating ligand. You can take another example also, oxalate ion. So in this example also, the oxygen is donating to the central metal atom. So there is a formation of ring between the metal and ligand. You can see here Fe with the ligand. So there is a ring between the metal and ligand. So there is a chelate between the metal and ligand. That's why we call as chelating ligand. So in today's topic, we discuss regarding what types of ligand and chelate and chelating ligands. Thank you one and all.